volume are included to the application. Let me call on class number 33, Francesca. You have the idea? No one? Yes, Francesca.
In real life?
Okay. Yes, yes, yes. How are you going to give some application of this one? Okay, later I'll go back to Francesca. Let me call on Denzel Cruz. Denzel, can you give me some application of this application or this relationship?
Sir, try only. Maybe in like how chips are not allowed in space because the bag, like the volume of air inside the bag is expanding, and then the chip bag is like exploded. It's burst open.
Okay, that's one of the application. But there's another one so that we can really think for this one. Imagine you're breathing. Imagine you're breathing. So what is happening to your lungs? Huh? When you breathe, what is happening to your lungs? Huh? Is it contracted or expanded? Huh? For example, inhale. So what's happening to your lungs? It's becoming expanded according to Akira and Roy. And when you, what? When you exhale, what is happening to our lungs? It is contracted. Okay? Or compressed. Okay? It will be contracted. So that is an example or the best example for Boyle's law. As the pressure increases, what will happen to the volume is what? Decreases. Okay? So that's why if you exhale, no? So this way, there's some entering. When you exhale, the pressure is increases. What will happen to the volume? It will be decreased. And then when you inhale, the pressure is decreases. That's why what will happen to the volume? It will increase. You get the point? Okay. So any other application in which it is inversely proportional regarding with the volume and pressure. Anyone? What is the best example? Sir, pumping a tire. Very good. Akira, can you discuss to us about this pumping a tire? Akira?
Yes, sir. Basically, the tire, there's no air or there's no, there's a hole in the tire. So when you're pumping a tire, you're putting on pressure. So when you put on pressure, there's an air or there's gas going inside the tire.
Okay, very good, Akira. So that's an example of the voice law. What else? Any other application of voice law? Last one. Anyone? Yes, you can see one answer. You want to share something?
Hello, can you hear me?
Yes.
The syringe ball used when
Very good. That's one of the best example also the syringe. Now let us hear Mackenzie how the syringe is the best example for this voice logo. Miss Mackenzie.
If you're going to use a syringe, you would need pressure to put in, for example, your COVID vaccine inside, which exerts pressure as well.
And what will happen to the volume, Mackenzie?
Sorry, I had to mute. They were reporting something. For the volume, which is the vaccine inside, it will decrease.
Okay, it will decrease. So syringe are the best example also for voice law. So only that one, no? Okay. So that is inversely proportional. In studies, no, it should be always directly proportional. Okay. If you're studying, make it sure that you will get a high grades, no? Or if you want to get high grades, then you have to study. Okay. It will be inversely proportional if you did not study and then you want to get high grades. You want to get high grades, but you don't like to study. You don't like to submit the task. Then it will be inversely proportional. Okay. So, any question with the Boyle's law? I think not, because we will jump already with the Charle's law. Hala ka, Charles Law naman ngayon, Sir Alex. So, allow me to present my PowerPoint presentation regarding the Charles Law. So, we're done with the Boy's Law. This time, let's talk about the Charles Law. Okay? And who's the proponent of this Charles Law? Anyone who could share about the proponent of the Charles Law? Who investigate this Charles Law? Hmm? Hello, 10A. Who investigate the Charles Law? No one? Okay. So the one who investigate the Charles Law is no other than John Jacques Charles. Okay. But before I present this Charles Law, which is the temperature volume relationship, I'd like to remind the 10A here. No, I have some reminders for you. Number one, okay, this is a simple reminder. The following person, no, if having the quizzes, I am very, very glad for those students who are turning in again that they're done taking the what? The quizzes, the seat work or something. But look at the others. They're turning in but no attachment. For example, to John Arquileta, to Gab Biteng, to Rancap. I don't know what is happening this one, but next time, make it sure if you will turn in, I can see like this, no? That it's done already the exam. Okay? Next, another. Out of 46, okay? Because 46, the 10A, if I'm not mistaken, there are 6 who are not yet turning in. Okay? But I don't know if it is done already. So these are the following person who are not yet submitting. So we have article number 1, which is the chemistry. Ralph Rodrigora and Thea Del Val. Are they present today? Ralph Rodrigora? Present? Who's the secretary? Let me check if Ralph Rodrigora is present. What about Thea Del Val? Thea?
Wala rin po.
Absent also. Very good, ha? Not attending the class. Okay, next. Converting units of pressure and temperature. They have 43 respondents. So who are those 3 students who did not take this one? Okay, so I hope and I pray that the others. Here are the following students who took the quizzes. So I check your name. Now we have Maria Ana Esguerra Leal, Austria Villanueva, Ramos Arquileta, Santos Tamayosa, Sibunga, Ranyola Cruz Eleuterio, Biteng Banyares Labares, Kilia Anabo, Gavero, Cruz Villena Manipon, Francis Rivera, Santos Bidamor Lakatan Sarsagat, Mamaril Pawi. Then still have another one. We have Katamko, Gondola, Rancho, Iana, Mambat, Lomoxo, De Luna, Cruz Rosalan, two Rosalan. Sarah, you have 2. I just repeated that one. Okay, Rancap, Vegas, Moira, Abigail, Dingal, Alcid, and Ralph Ian Rodrigora. Who am I did not called in this quiz? Let me know. Huh? So here, Ralph Rodrigora is here already. Okay, so that's the one, huh? Please update. This is my first time that I'll do this one. Next time, whether you have or you don't have, I will not update you anymore. Please do check your G Classroom to all the activities. Okay? Gets? Ralph, are you hearing me? Wrong link po pala yung sinalihan ko. Ralph, you can hear me? Use your microphone, Ralph. The article, ha? You're not yet submitting. Okay, anyway, let's proceed already with the Charles Law. Okay, please, the article, Ralph, ha? Do submit that one. Okay, this is my first time to repeat. And then there are some class number that you are 2. For example, class number 21. Okay, sir, in the quiz, How's the question? Sir, in the quiz, we still need to resubmit the quiz link. As much as possible, screenshot. Okay? That's the one. So that I know that you are done already. Okay? So that's the one. Next, class number 2. In this classroom, I think there are 2 class number 2. Okay? Next, class number 5, number 15, number 25, number 31. Okay? Those who are not yet having the quizzes, if I'm not mistaken. Class number 23, I think you have 2 class number 23. I don't know who's that one. You check your class number because when I check the G classroom, it's 2. Okay? So you double check that one, ha? 10A. Wake up, and then all the activities, please do that one. For those students, for example, you are late in passing the things, automatic you have the deduction of 5 points. That's the rules of Sir Alex. No, that's why you need to submit that one on time. I know that you are doing a lot of things, but please be careful in submitting and follow the time because sometimes I might forget, but I'm giving you the time to answer still. No, because your schedule is together with the physics one of grade 12. That's why sometimes I forgot if I'm doing a lot of things. So just please remind me. Then again, if you're chatting me or you're sending messages no in the FB, I'm not reading while I'm having my class. That's why I cannot sometimes see all the messages. So sorry, I'm not using my phone if it is like that. No. Okay, so only that one. So please do submit all the activities. Ralph, would you mind to turn on your camera? So going here to the Charles Law. Charles Law is the temperature and volume relationship. So what's the difference between Charles Law and Boyle's Law? In Boyle's Law, pressure and volume. In Charles Law, temperature and volume relationship. So let's have this one. It was proposed by Jacques, okay, Alexander Caesar Charles, okay, and Charles Law stated that at a constant pressure, the volume occupied by a fixed quantity of a gas and it is directly proportional to its absolute temperature. Again, the volume occupied by a fixed quantity of a gas and it is directly proportional to its absolute temperature. So meaning to say, no, just like what we said a while ago with this relationship, temperature and volume relationship is directly proportional. When we say directly proportional, as the temperature increases, what will happen to the volume? The volume will also increases. And vice versa, as the volume decreases, the temperature will also decrease. So please memorize that one, huh? And do not confuse with the Boyle's and Charles. Boyle's law is inversely and Charles' law is directly proportional. Okay? So always remember that the temperature in Charles' law is always converted into Kelvin. And how are you going to convert the degrees Celsius to Kelvin? Then you have to add 273. Isn't it just like what I told you last time? We will not use anymore the 273.15, but instead you do already the 273 so that it will be easy to your part. Okay, because I know if there's a point, sometimes you cannot compute manually. You will use calculator. Okay, next. And if it is Kelvin going to degrees Celsius, then you have to subtract 273. That's why last time I'm really giving you the conversion unit so that you will be familiar with this one. Okay, next. So for Charles' law, here is the general formula. We have V sub 1 times T2 is equivalent to V sub 2 times T1. Okay? V sub 1 times T2 is equivalent to V sub 2 times T1. Where T1 is the initial temperature, here's the initial temperature, and T2 is the final temperature. For your V1, that will be your initial volume. And for your V2, that will be your final volume. Okay? So, let us try this. Um, Allow me to change my camera, ha? Okay? I'm going to use again the other camera. Okay? So, last time I asked you about the different formula regarding with the given no in the Boy's law. Now, we said that B1 times T2 is equivalent to V2 times T1. Okay? Is it visible, the handwriting? Is it clear? Let me know if you can see my handwriting. Please do the thumbs up if you can see my handwriting. Okay. It's big or it's fine to your eyes already. Okay. Now, imagine this is out the general formula for Charles' law. What if B1 is unknown? What we will do? Same process just like what we have last time. So if B1 is unknown, then B1 is equivalent to, what's the formula? Let me call Gabriel. Gab, what's the formula for B1 this time?
Um, V2 times T1 all over T2.
Very good. All over T2. So that's the formula for our V1. What about for V2? Anyone who could give me the formula for B2? May I call on Akira? Akira, what's the formula for V2?
Sir, these, ito, sir,
Okay. Okay, I'll go back to Akira. Anyone who could give me the answer for our V2? Who can give me the answer for the formula for B2? Yes, Jake. What's the formula for B2?
B sub 1 times
T
B,
sub 1
ay, T
times
sub
T
2,
sub 2 all over.
T sub 1.
Okay, T sub 1. Very good. What about for T1? T1? What's the formula for T1, Nathaniel?
Sorry po, I didn't notice po I was muted.
Okay.
If it's T1 po, is
Yes.
it wait po, T1, is it
This is the general
V
formula.
T1, is it
Yeah. T1 is ano?
V1,
Okay. Yeah.
V1 times
V1 times
T2
T2 all over
over V2.
V2. Very good. Okay, so our T1 is V1 times T2 all over V2. And the last one for our T2. Okay, T2 ha, not tita. T2. Okay, Jello. Jello, what's the formula for T2? Okay, Jello Moira. Anyone who could give me for T2? Okay, Carl, Kevin, Dingal. What's the formula for T2?
I don't know, sir.
Okay, for T2, imagine that this is the general formula. You have to cover this one. Then after that one, what you will do? You have to copy this one. Then beside that is over. Remember? Okay. Let me call on Abigail. What's the formula for T2?
Sir, T2,
Yes po.
V sub 2 times T sub 1 over V sub 1 over
V
V sub
sub
1.
1. Okay. So T2 is V sub 2 times T sub 1 over V sub 1. Question with the formula. Okay. Did you do the screenshot with the formula? Okay. I hope you do the screenshot because some of you are confused still. Okay, so let's proceed with this formula. Let's get it on. So remember the STP. Just wait, I'll change my... Next time, I'll go to the fourth floor just to have the discussion in the blackboard. No? So remember the STP. What is STP? STP stands for standard temperature and pressure. So there. So for the temperature, always convert it into 173 Kelvin or it must be in Kelvin. For pressure, remember 1 atmosphere. Okay? That will be the pressure. Now, what happened? Okay, let's try this example. The temperature inside my refrigerator is about 4.0 degrees Celsius. If I place a balloon in my fridge that initially has a temperature of 2 degrees Celsius and a volume of 0.50 liters, what will be the volume of the balloon when it is fully cooled by my refrigerator? Again, the temperature inside my refrigerator is about 4.0 degrees Celsius. If I place a balloon in my fridge that initially has a temperature of 22 degrees Celsius and a volume of 0.50 liters, what will be the volume of the balloon when it is fully cooled by my refrigerator? So let us check this one. Okay, let's have another one. Okay, just wait. So what are the given in the formula, my dear 10A? Huh? What are the given in this formula or in this given? Anyone who could tell me the given here in problem number 1? Okay, according to Nathaniel, 4.0 Celsius. What is that 4.0 degrees Celsius, Nathaniel? Is it T1 or T2? Huh? Okay, are you sure that's T1? Okay, so that is, okay, read the problem, huh? It's written there, the temperature inside my refrigerator is about 4.0 degrees Celsius. If I place a balloon in my fridge, okay, that is initially has a temperature of 22 degrees Celsius. Okay, so this 4.0 degrees Celsius, it will be your T2. What else? Aside from T2, which is 40 degrees Celsius, what else are the given here? Yes, Carl. Okay, according to Jordan Clyde Iana, your T1 is equivalent to 22 degrees Celsius. Okay, so we have 22 degrees Celsius for our T1. What else are the given here? Yes, Francis.
0.50 liters po.
What is that 0.50 liters, my dear?
V1 po.
Okay, 0.50 liters, that's the B1. And the unknown here in this problem is what? So it's stated already. Yes, we have the V2. Very good, Manipon. Okay, and what's the formula for V2? What's the formula for V2? A while ago, we stated already. What's the formula for V2? Yes, Carl, what's the formula for V2? V2 is equivalent to... Hello, Carl.
B1 times T2 over T1.
Okay, so for our V2, we have V1 times T2 all over what? T1. Okay. Can we proceed already? Huh? Can we proceed already? Can we proceed already with the computation? Can we substitute already?
Yes po, sir.
Yes, according to Carl. But look at you. You're not listening. I told you, temperature must be converted into Kelvin. So we need to convert first the temperature into Kelvin. Yan tayo eh. Okay? So what we will do? Convert the T2 and T1 into Kelvin. And what's the answer for T2? So you need to convert that one into Kelvin. So meaning to say 4.0 plus 273, then the answer is, what's the answer? 281 Kelvin. Very fast in doing the calculator, no? So we have 200. What's the answer? 281, correct, Denzel? 281 Kelvin. Oh, there are some answer 277. What is that 277? Who said 281? Okay. Oh, 277. Ha? Come on. 273 plus 4 only. 273 plus 4 is equivalent to 277. Why 281? So 277 Kelvin. What about the 22 degrees Celsius? 22 degrees Celsius plus 273. The answer is what? Very good. 295. I hope it's visible, ha? Okay, 295. So, can we proceed already? Can we substitute already the given? Let me hear the 10A. Nagkukulisin ako magpo-proceed na. Oh, can we proceed already?
Yes po.
Okay, there. It seems that, who's that one? Is it Rankap? Rankap, you're the one who said yes po?
Me po.
Okay, so who's that? Jordan. Thank you so much, Jordan. So we can proceed already. So with that, no? So let's get it on. Our B1 is 0.50 liters. Sir, are we going to convert the liters into ml? No need, because that is only liters. No need that one. Huh? Okay, because no, what? There will be no problem even though we include this one. Multiply with our T2, which is equivalent to 177 Kelvin. All over, what's our T1? Our T1 is 295 Kelvin. So with that, what we will do is to cancel this Kelvin and Kelvin. Then let's proceed with the computation. 0.50 times 277 divided by 295. Then our V2 now is, what's our V2? Compute. What is the answer? You can type your answer in the chat box. Very good. The answer, Pawi. Pawi, John Marlon, Cyril, Aldea, Kate, Gian, Sarah, Roy, Nathaniel, Bernadette, Gabriel, Abigail, Jello, Maynard, Maria Ana, Guerra, Joshua, Madeline, John, Arquileta, Jordan, Akira, Renz, and so, okay, all of you, I think. Denzel, Luis, Jody, thank you so much for those who answered there. I hope next time you use your microphone, ha? Okay, so the correct answer is 0.47 liters. I'm very happy to the grade 10. Why? Because they got already the general rules of Sir Alex in terms of the decimal points. At least you round off the hundreds place. Very good. Let's give our virtual claps to the A. Nice one. Okay. So the correct answer here is 0.47. Okay. So what have you noticed here? Okay. Look at this one. Okay. If I will put here the answer of B2, 0.47 liters. Okay. What happened to the temperature? On 22 degrees Celsius, it became 4.0 degrees Celsius. Remember? Or from 295 Kelvin, it became 277. Same with this V1. From 0.50, it became 0.47. So as the temperature decreases, the volume also will decrease. Have you noticed the changes in the A? So that's their relationship. Question. Okay, let's try another problem. Okay, let's try this problem number 2. May you read this one? Yes, Joshua.
A man heats a balloon in the oven. If balloon initially has a volume of 0.40 liters and a temperature of 20 degrees Celsius, what will the volume of the balloon be after he heats it to a temperature of 250 degrees Celsius?
Thank you so much, Joshua. Now let's go to problem number 2. What are the given in the problem? Okay. Who can give me the given? Yes, Kate. I want to hear your voice this time. Kate, what are the given in the problem?
V sub 1 is 0.40 liters.
Okay, B sub 1 is 0.40 liters. Then what else?
V sub 2 is missing.
Okay, so you found already the missing, which is the B sub 2. What else?
T sub 1 is 20 degrees Celsius.
T sub 1 is 20 degrees Celsius, and the other one?
T sub 2 is 250.
Okay, T sub 2 is 250 degrees Celsius. So, Kate already given, Kate already gave the unknown, which is the V2. Okay. May I hear the voice of Chanel? What's the formula for V2? Chanel?
T1 times T2 over T1.
Over T1. That's for T2. Okay. Can we substitute already? Can we substitute already? Not yet. And what we will do? Yes, Adea.
We will convert the temperature to Kelvin first.
Okay, very good. Need to convert the temperature into Kelvin. And if we're going to convert this one, Jordan, 20 degrees convert to Kelvin. The answer is
293 Kelvin.
293. So we have 293 Kelvin. What about for T2? If you're going to convert that one, Bernadette, number 27.
The answer is 523 Kelvin.
500?
23 Kelvin.
523, correct? Huh? Is this your answer also? An A. Okay, shall we proceed already with the computation? We can now substitute the given, no? So here we have our V1, which is 0.40 liters, multiplied with our T2, which is 523 Kelvin, all over. Okay, our T1 is 293 Kelvin. So what we will do this time is to cancel the Kelvin. Then what is our answer for our B2? Proceed to the operation. 0.40 liters times 523 divided by 293. The answer for V2 is 0.71 according to Roy. Very good, Roy. No? Oh, why the others having 0.22? What happened to Cyril? Sai, what happened to your answer? Why 0.22?
Wrong for the computation.
Okay. It's okay. No? So the answer is, let me check. Okay, 0.40 times 523 divided by 293. The answer is 0.71. Okay, very good. 0.71 liters. So this will be our answer. Question 10A regarding with our Charle's Law. Question? It's clear? Okay, let us have another example. Okay, you'll be the one to answer this, for number 3. Okay, according to the number 3, on hot days, you may have noticed that potato chips bags seem to inflate, even though they have not been opened. If I have a 250 ml bag at a temperature of 19 degrees Celsius and I leave it in my car, which has a temperature of 60.0 degrees Celsius, excuse me, what will the new volume of the bag be? Okay, I'll let you to compute first before we have this one. Okay. Okay, if you know the answer, you can put in the chat box your answer and A, huh? But make it sure, don't forget the unit, huh? Or maybe you're thinking, why Sir Alex is not yet giving the quiz for the boys' law? Maybe we forgot this one. During your offline activities, that's the time that I'll give you the quizzes. Huh? So maybe expect the unexpected. Next week, you will have a lot of quizzes regarding with the boys' law, Charle's law, and whatever will be the next topic for Friday. So anyone who could put their answer in the chat box, maybe you can put already, compute. Okay, according to Daniel, with question mark, 285.10 ml. Let us see later. Okay, so I hope everything is done. Let me see. No, let us try to answer. All of you are done already. Type your answer in the chat box so that we can recognize your name. So here are the following given, or what are the given in the problem? Let me hear the voice of Luis. Luis, let me hear your voice. Please please turn on your camera, guys. Some of you are off the camera here. Ralph, Akira, please turn on your camera. And Luis. Okay. Luis, what are the given in the problem?
Sir, the given is the V1 is
Okay, what's V1?
is equals to 250 ml.
Very good. Next.
And the V2 is missing.
Okay, the B2 is unknown. Next. What else?
And the T1 is 90 degrees Celsius.
19 degrees Celsius. Next. Very good. Last one.
19 degrees Celsius. The T2 is 60.0 Celsius.
Degrees Celsius. Very good.
Degrees Celsius.
So here are the given. So we have the B1, which is 250 ml. V2 is unknown. T1 is 19 degrees. T2 is 60.0 degrees Celsius. Then what is the formula for V2? Yes, Roy, we want to hear a voice. Roy Banyares. The formula for V2 is?
V sub 1 times T sub 2 over T sub 1.
Very good. So we have B sub 1 times T sub 2 over T1. Then what we will do is to convert first the T1 and T2. If we're going to convert the 19 degrees into Kelvin, then what's your answer, Chanel?
333 po.
Come again. Chanel, may you repeat your answer? 300. Chanel.
It's wrong po pala. It's 292.
292. That's why, 292 Kelvin. And what about for 60 degrees Celsius, Chanel?
333 po.
Okay, 333 Kelvin. So let's substitute the value this time. For our B1, that is 250 ml, multiply with our T2, which is 333. Why 33 only here? So that's 333 Kelvin all over 292 Kelvin. So what we will do this time is to what? To cancel. Cancel Kelvin, cancel Kelvin. Then for B2, the final answer is what? So multiply 250 times 333 divided by 292. Then the correct answer is 285.10 ml. 285.10 ml. Question, who among you got the correct answer? Wow, job well done, 10A, no, sir? Can I go to the Can I get to the CR? Yes, and so you may proceed to the CR. Okay, so it's clear already the Charle's Law? Clear. Question. Okay, if no question, Sir Alex will give another problem. Practice. Okay, go with this one. A soda bottle is flexible enough that the volume of the bottle can change even without opening it. If you have an empty soda bottle, which has the volume of 2.0 liters at a room temperature of 25 degrees Celsius, what will the new volume be if you put it into your freezer, which has the negative 4.0 degrees Celsius? Teacher, always the B2 is unknown. No more the other one. It's okay, so that you will use to it the B2 because I know that you are very good in doing the formula. Okay, proceed. Okay. So if you know the answer, you can put here in the chat box already. Remember, the other one is negative 4.0. Okay. Don't forget that one. Who among you are not yet reciting? Did I call all of you already? I think class number 32, not yet. Madeline, not yet also. No? Let us see. So the only absent this time is only Thea, correct? Yes. Yes, Bobby. Ay, sorry. Here. Yes. Thank you so much, Bowie. Welcome. They're asking, sir, if we have quiz of this, are we allowed to use calculator? Nathan, what do you think is my answer? He'll be the one to answer, Nathan. Ha? Nakasalalay sa'yo ang isasagot ng lahat. What is that, Nathan? You want to use calculator? Nathan, I'm asking you, you want to use calculator? Yes po. Then the answer is yes. You are allowed to use calculator 10A. Okay? Of course. Because it will be hard, no? If it is manually, it will be hard. But I have some comment, no? If you will put your, for example, your computation, you can put first the picture in the MS Word, no? And then you compile it, and then that's the time that you have to save that one. Then that's the one that you will upload in the G form. Because if you will put it one by one, the picture, it will be hard for me to check. Because sometimes I'm checking the computation inside the G Classroom, inside the G form, no? Okay, so that you will not have problem anymore. Then another computation, please do properly your handwriting or penmanship. No, Sir Alex doesn't know how to read the prescription of the doctor. Yung mga sulat yung kinalahig ng manok, I cannot read. That's why, no, if that one, I'll put minus next time because what's the sense of having the computation and then your handwriting I cannot read? So make it sure the handwriting is nice or your penmanship. Okay? Because sometimes, even though without computation, you're doing the computing as if you're computing. Or just to have the computation solution. Okay? Next time, make it sure it's clear. Okay, some of you answer here 215. The other is 200 or 1.81. Okay, let us see. We have double. The other is negative and the other is 181 and the other is 2.15. What is the correct answer? Okay, let me call. Okay, what about the others? Done? Okay, I want to call Roy Banyares because your answer is 2.15. Roy, can you show to me your computation, my dear people of the Philippines? Would that be possible? Regarding with I'm wrong po, teacher. Ay, umami na kagad. I'm wrong. I didn't see the negative. Oh, I just said already a while ago the negative, Roy, ha? What about to Denzel? Denzel, you said your answer is 2.15 liters. Denzel? First, Denzel.
I didn't mind the negative.
The negative also. Okay. So let me hear the voice of Jordan Clyde. Let's hear the, sorry Jordan, I called you already. Madeline. Madeline? Claire?
Yes po, sir.
May you give to us your computation? Can you show in the camera your computation so that it will be visible? Okay, there. So you just spin. Okay, very good. Following. Very good. Okay. So what are the given in the problem? Claire?
V sub 1 is 2.0 liters. V sub 2 is
liters.
unknown. T sub 1 is 25 degrees Celsius and T sub 2 is negative 4.0 degrees Celsius.
Very good. Now what we will do is to convert the 25 degrees Celsius and negative 4.0. Okay, Jake, if you will convert the T1 and T2, what's the answer?
The T1 will be 298 Kelvin. Then T2 will be 269 Kelvin.
Very good. And then if we will substitute already the given, the correct answer is, Sarah, may I hear your voice? What's your answer?
Me po.
Yes, Sarah.
The final
Class
answer
number.
already.
Yes po.
1.81 liters po.
1.81 liters. Actually, there are two Sarah, no? Sorry. So, 1.81 liters is the correct answer. Very good. So, at least you know already how to derive or how to compute, no? Any question with the Charles Law? Okay, so always remember Charles Law, it is directly proportional. As the temperature increases, what will happen to the volume? The volume will also increases. Then vice versa, as the temperature decreases, the volume will also decrease. Can you give me some application of this Charles Law? What are the real life situation of the Charles Law? We're talking about directly proportional. As the temperature increases, the volume will increase. The best example for Charles Law is the clue. You can see this one in the, according to Gian, breathing. Okay. What happened to, there, Jody, very good. The hot air balloon. Okay, Jody, can you explain to us the hot air balloon?
So, the hot air balloon, where there's this thing where you can light it up so that it can float. So, if you, how do I say this? If you add up more fire, the balloon will lift it up. So, it's like, the more pressure you give, the more volume it will also receive.
The more temperature,
if the temperature increases, then the volume will also increase po.
Yes, okay. Because the constant here is pressure. Don't forget that one. Okay, so one of the best example for Charles' law is the hot air balloon. Did you remember Hackpin and Tom Sawyer? You know that movie or you know that cartoon character, isn't it? No? There's it, it's alien, and then suddenly Tom and Hack really have those, in Tagalog, it's siga, so that they can have this high temperature so that the hot air balloon can be bigger. Okay? I read breathing according to Gian, Beliana. Gian, would you mind to explain the breathing in terms of the directly proportional?
Certain unit po.
Come again, Gian?
Certain unit po.
A bit, how do you call this one? It's not choppy, but okay, we can understand. It's okay.
In breathing po, when the lung expands po, and when you breathe out, it compresses po.
Okay, thank you for that idea, Gian. But again, so that you will not be confused, the example for Charles' law is the hot air balloon. Remember, temperature and volume relationship. So it's already 1:41. Thank you so much for listening, 10A. I know you got something